Our next speaker is Dr. Christina Phillips, who works for Smithfield Foods. Dr. Phillips is going to talk to us a little bit about power in our field trials or in our controlled research trials, and ultimately, does sample size matter? Okay, Dr. Phillips is going to give us her insights about that topic, and please join me in welcoming her to the stage now.
Hi, everyone. I'm Dr. Phillips. I am the Director of Production Research here at Smithfield Foods. As a matter of fact, next Monday marks 10 years for me here as an industry research scientist. Just a little bit of background about myself for those of you who don't know me. My education includes a master's in swine nutrition from North Carolina State University and a PhD in swine welfare from the University of Minnesota. What's kind of funny about me giving a presentation entitled Sample Size Matters is that while in school, statistics really was not my favorite subject. Unlike my office mate who simultaneously earned a master's in statistics while she was earning a PhD in animal science. However, taking several statistic courses because I had to, my committee made me minor in statistics, and having a statistician on my committee both served me well in the long run by really laying a solid foundation for me to continue learning about the importance of statistics in animal science. Someone once told me when I started this position that I would learn more in my first year working in the industry than I did for all of my 9.5 years of college. And I can tell you that they were exactly right. That first year was like drinking water through a fire hose. But the fast pace of the industry, although challenging at times to constantly, daily, reprioritize tasks based on industry needs, is absolutely exhilarating. As I began to prepare for this talk, which is my first ever without slides, by the way, wasn't excited when I found that out. I started to brush up on the statistical terminology and really try to memorize key definitions, right? Experimental unit, the smallest entity to which one application of a treatment is applied. Coefficient of variation, CV, measures the unexplained variation that occurs among experimental units that are treated alike. It's referred to as experimental error. We know that high CVs make treatment differences difficult to detect, and low CVs make treatment differences easier to detect. And lots of other definitions: sample size, null hypothesis, alternative hypothesis, type 1 error, type 2 error. I'm not going to bore you by relaying all of those definitions. But as I Googled how to give this type of talk, Marcio gave us some links, I learned that it's more about the fleshing out of an idea with evidence and observation and provoking thought. Perfect. I can do that. I'd much rather do that than memorize definitions anyway. So I'm going to talk about why sample size is important. You can Google how to calculate it. There are lots of available tools online. In this talk, I've chosen to really highlight 3 ways that I use sample size every single day in my job. Yes, every day. It's kind of hard to admit that statistics is so important. So as you can imagine, working for a large swine production company like many of you do, we get lots of sales calls and emails. I really want to quickly add, we want those calls and emails. Keep them coming. We want to be on the cutting edge of any potential ideas or technologies that can improve our business and what we do every day. So again, keep them coming. But because of that huge influx of information and contacts, it's important that we have a set of processes internally in place to prioritize those potential technologies and ideas, right? And so we want to be given previous research. We're not a contract research organization. We're a pig production company. We have limited internal research resources. We want to ourselves, with our own confidential sensitivities, determine what the potential economic benefit of those ideas are to our organization. And we really need to determine and rank all of those ideas that are coming to us so that we can decide and prioritize what are the highest potential economic benefits to our system. So this is where sample size first comes into play. This is number 1 and why it matters so much. When I review externally conducted research or sales materials, it really can be easy to get caught up in the hype of the presentation. They're good at what they do, right? And they should be. So during those meetings, I always ask for some information, okay? You can't be shy. So what's the cost of your product or idea? What's the potential benefit to my production system? Tell me in terms of key metrics that are important to my business. Is there going to be an improvement in average daily gain? Is there going to be an improvement in feed conversion? Am I going to have a decreased mortality or decreased mortality and morbidity? Tell me that information and let me calculate what the potential return over expense is for my company, again, using the information that we have internally. And then 3, don't just tell me how wonderful your product is. Give me research that backs up those claims. Okay? So along with comparing important attributes of the research that I'm presented to our production system, things like genetics, wean age, housing, space allowance, all of those types of things. What was done in that study to what we have across our system? Those are really important questions and comparisons to make when you're evaluating literature. But it's also equally important to ask questions regarding statistical soundness of the data that you're being presented. What's the experimental unit? Is it the pen? Is it the pig? Is it the litter? Is it the barn? What was the difference to detect expected for the sample size of the study? Based on those questions, we can then determine if we agree with the conclusions that were drawn and that were being presented, and if they make logical sense. Are they repeatable? A potential negative to ignoring sample size in this process could be an incorrect ranking of the economic importance of a potential idea for our business. One such example is being presented with data that shows no significant differences in performance. Maybe the N is 5, maybe it's 10. But at the end of the presentation, there's claims that you can take one product out and switch it for another equal cost product with no negative impacts on performance for your business. Can you really? What was the sample size calculation? My company is relying on me as a research scientist in my training to figure out these types of things and bring them to light. So that's the first way I use sample size every day. The second way I use sample size is developing research projects. So a project idea ranks high and it makes it through our rigorous internal evaluation, which includes calculation, like I said, of a potential return over expense and understanding of the previous research. That makes us think that the results that we presented could be reduced research system. And then we make a decision to conduct a trial internally. This is where sample size comes into play. This is the second way I use sample size every day. And I think most people actually find this the most logical step. This is where people, I think, would pick out that we would use sample size. The research scientists designing protocols, it makes sense, right? But I also think it's sometimes overlooked or ignored due to certain potential perceived constraints. So replication, sample size, for an experiment should not be determined based on cost of availability of animals, housing, convenience, even length of an intern's internship, right? Which I may be guilty of at times. But a power analysis is important for 2 main reasons. It ensures that I, as a scientist, do not waste my time. I don't waste the company's research resources carrying out an experiment that has little chance of finding a significant effect if there is one. And 2, it also makes sure that the research resources are not wasted by including more experimental units than are actually necessary to detect an effect. So I think the former is more common. I think sometimes in our hurriedness to answer questions quickly, we need to stop and ask, what was the sample size calculation? What was the power? And are we confident that that is enough in enough experimental units to answer the question and meet the objective of the trial? Execution of the trial itself with attention to detail is more than important. This is what my team does every day. We ensure correct feed manufacture. We ensure that once the feed is manufactured, it's loaded out into the correct loadout bins at the mill. It's loaded into the right pockets at the truck. It's delivered into the correct feed bins on the farms. That pins are allotted to trials correctly, that our equipment that we have in place to collect all of the necessary data for the trial is calibrated and ready to go, that our people are trained in all of the recording aspects of the data. All of that is extremely important. But let me remind you, it all starts with sample size. So are there exceptions to the rule? Is there any time that we would do research and not calculate a sample size? Yeah, there is. Pilot studies. The value of pilot studies absolutely should not be ignored. but we should agree on the definition of a pilot study and how the conclusions of a pilot study should be used, right? So a pilot study is a small scale study. It's preliminary. It aims to investigate whether there's crucial components of a main study would be feasible. A pilot study is not a hypothesis testing study. When we consider doing pilot studies, we ask ourselves three important questions, and they all have to have an answer to a yes. And that's when we decide whether or not we would take a novel idea that may not have previous research completed on it and actually do a small pilot study internally. We ask ourselves three questions. Is the concept practical and promising? Are there minimal resources necessary to answer the question? And by minimal resources, I'm not only talking about animals, I'm talking about my time, the researcher's time, labor, all of those things, minimal resources. And then three, would the conclusion be worthy of continued assessment? Again, if we can answer three yes to all of those, then it's possible that a pilot study would be a worthwhile endeavor. Lastly, and number three, I mentioned that what keeps me most energized and engaged in my current position is really the fast pace of the industry. When I first started, I was surprised to learn that oftentimes a production decision is made and implemented, and then kind of a research trial project may be designed to support and or defend or potentially debunk that change. But sometimes if a potential change would be a large enough system-wide change, upper management will actually want to wait for the research results. And what I mean by wait for the research results is not patiently wait. The knock on my door, how's the study going? What do the results look like so far? Any preliminary look at the data? These types of questions used to really make me feel uneasy. Like the expectation for me was to know all of the details for every single trial I was conducting, which earlier in my career may have been not such a high hurdle. But today, as we have increased efficiencies, as we've learned, as well as additional research resources, I really felt like I was failing to meet those expectations. But what I learned is to pay attention. Pay attention to which research projects that upper management is most interested in and be ready with talking points. Not an answer for what the data looks like only 4 weeks into a 12-week study, because sample size is important, but instead a concrete answer on when the project will be finished with a set deadline that I know I can meet. And frankly, that information was appreciated and is appreciated. And I feel a sense of accomplishment by giving that information and it being a worthwhile answer for them. And knowing that the information that our group provides to upper management is well respected and used to make better business decisions. Not providing a preliminary analysis that could lead to a different conclusion at the end of the study, because sample size is important. Finally, I'll wrap up with producers rely on their internal scientists for three major things: review research conducted externally and determine its potential economic value and applicability to your organization. And also to conduct, but remember, sample size is important, so complete appropriately designed experiments before sharing results. Sample size cannot be ignored in these three processes. Big economic decisions are made based on the outcome of experiments and what is deemed to be the conclusions and implications for a business. Just a really small example, a diet cost difference, maybe of $40 per ton per se, or 2 cents per pound on a 10 pound per head feed budget across all of our 18 million pigs is a $3.6 million question. It's my job to make sure that answer is a correct one. Sample size is key in that equation. Identifying opportunities and conducting research trials to evaluate those ideas and their application to our business is only part of my job. The other part, which is really satisfying to see come to fruition, is to see the implementation of the results of those trials across our organization, alongside my colleagues in the groups that are responsible for implementation. My colleagues in production, nutrition, veterinarians, feed mill managers, etc. and work with our internal accounting group to then track implementation of those projects to achieve economic benefit. It's important to remember, and I remind my staff that work in research here at Smithfield, that not every trial is a home run. Not every trial results in economic savings. Not every trial results in an added benefit. But it's important to be critical in the evaluation of potential ideas and ensure steps of the scientific method are followed, including calculating sample size. Then we can be guaranteed that the outcomes for research and the returns on invested research funds within our company are enhanced. So thank you for your time.
Thank you, Dr. Phillips. I think you did an excellent job taking a dense technical and scientific topic and communicating it in very practical terms with nice examples of how you share that information with your team in the field. One of the things that strikes me is that, statistics and power can be dangerous in both directions. Studies may be not powered up enough to detect the difference, and then vice versa. Could you talk to us a little bit about the danger in looking at data that demonstrates a p-value that looks wonderful and meets our threshold, but maybe it's detecting a difference that could not be real because the study might be overpowered? Is that something you get concerned with?
I would say yes. We get those questions a lot. I get reminded from my colleagues that the trials that are completed under one set of conditions, right? It's one research farm, one group of pigs. They have one health status that may be vastly different from the health that's happening in other parts of our business. And so what's important and what's key when we're determining what results and implications are for a study is to present the information and also say which variable the sample size was calculated for. So to your point, we may have calculated a sample size for average daily gain, but we saw a difference in mortality. Well, that seems a bit odd because usually our sample size for detecting mortality would be quite a bit larger. And so what we try to do is we try to dig into what are what else is happening there. We collect information on health as the animals grow. We have information about the environment. We record temperature and humidity in the barns as the animals grow. And we try to find, are there additional factors that are having an impact on the results other than the treatments that we've applied, right? We test our feed samples for nutrient content to make sure that, yes, they were manufactured correctly, but also maybe mycotoxins slipped in there somehow, right, out of our control and had an impact on the study. So the answer is yes. And the other thing I'll say to that question is that repeatability is key. I would like to think that for the majority of the studies that we find internally that have a positive impact, we're going to repeat that again before we go and implement that across our business. We want to make sure that the results are reproducible on different groups of pigs raised under different conditions.